All right, our next speaker is Justin Norman, Director of ML Research and Services at Cloudera, presenting on why is production ML so hard. Previous to his current tenure as Director of ML Research and Services at Cloudera, Justin was a Senior Technical Advisor at Dexon Telemetry, a startup providing remote equipment monitoring. Before that, he was a Senior Manager of Applied Machine Learning at Fitbit and spent 5 years at Cisco. He attended the U.S. Naval Academy and holds a certificate in technology commercialization from USC's Marshall School of Business. Please welcome Justin Norman.
Hey, everyone. I'm actually really excited to maybe change the conversations on his axis a little bit, because I think you've probably been hearing from a lot of people who are talking to you specifically about the tools, the techniques that are required to execute production ML. And believe me, I'm into all that stuff too, but it's a highly religious conversation, so I'm happy to not be having that with you and talking a little bit more about why we're doing this in the first place. From a research perspective, I think many of you are probably in the same space. If you don't understand the problem you're trying to solve, then all the solutions and all the tools you come up with in the world are likely going to miss the mark. So I thought I'd spend a little bit of time speaking to you about what we've learned at Fast Forward and what I've learned throughout my career, actually building and scaling machine learning applications for several different enterprises. But before we get started, I wanted to talk a bit about why you should listen to what I have to say, which I realize, given all the opinions going on, it should probably be at least introduced. So our organization is called Cloudera Fast Forward Labs. It was an acquisition into Cloudera proper about 2 years ago, founded by Hillary Mason. And the whole idea was to take a look at what was happening in industry, government, academia, really from a research perspective, so literally at the papers level, and then try to consolidate that down into practical knowledge that could be used in a company, whether that was a startup, and of course at Cloudera, more relevant in the enterprise space of things. So to do that, we put together a team, like the Avengers, of a bunch of really interesting people who had backgrounds in computer science, but also design, electrical engineering, neuroscience, human-computer interaction, all those sorts of things, because I think it's really important to have that sort of collaborative approach to solving problems. It can't just be a comp sci problem. And yeah, I'm a computer scientist by education, but that's only one small sliver of what we actually are trying to build here from an application perspective. We also are startup people, and we're also enterprise people, which makes for awesome debates on our table. Usually, the startup people are telling us about how we're not moving fast enough, and the enterprise people are telling us about risk. And that's a good intersection to get into. And we also like to write a lot. So if you want, follow me on Twitter, follow Fast Forward on Twitter, and you'll get a lot of opinions about all the things that you're probably hearing about too from our perspective. So that's who you're talking to. In terms of why we're having this conversation, so from a Cloudera and Fast Forward Labs perspective, we tend to define machine learning a little bit differently. So, I think if you go to the traditional definitions, you'll speak a little bit more about the tools and techniques, algorithms that are applied to specific data sets to find a pattern, and then you are trying to answer some question with that pattern recognition. That's great, and I think that's true to some extent. But what we're talking about is actually making these transformational, broad capability changes in organizations. So, like, we like to think about the Google effect, or like what's happening with ride sharing, where you have an entirely new category of business that wouldn't have been possible without this scale of technology and this new technique adjustment. And that's really where we're focusing a lot of our research. So again, just a bit of calibration for all of you about what we're going to be talking about today. So all that stuff's really fun, and we should do that. But turns out it's really hard, and I think most of you probably already know that if you've tried to do it at all. And if you haven't tried to do it, once you get done writing your code in your notebook or in your PyCharm session, and you give it to someone else to actually run as a production system, you'll realize right away that mainly the things you're working on from an ML perspective are actually just a small sliver of what the actual enterprise system is going to be. This is from a Google paper. It's from a few years back, but it actually is still really relevant. They talk about all the different things that it takes to actually bring to an enterprise or bring to production in a machine learning or data science system. And as you can see, the ML code, you probably can't see it because it's the small little dark box in the middle. That's the part that you wrote as a data scientist or an ML researcher. So if that doesn't give you some perspective on what actually matters in the ecosystem, I don't know what will. So it's really interesting because from a PR and a marketing perspective, we have this like sort of outsized importance on the technique skill set that's really being driven really to the C-level. So everybody who's making, who's cutting checks and making decisions thinks that those people are the ones that we've got to take care of. But at the end of the day, actually it's a much larger, much more broad ecosystem that we need to satisfy. And that includes things like monitoring, serving infrastructure, of course, orchestration, what's required for process management, integration through APIs. There's so many other things that have to work in tandem in order for that machine learning code to be relevant. And I think all of you probably know, but when you interact with an ML system on your phone, there is a massive backend that is communicating very, very quickly, but still communicating together to make that a possibility. So I'm going to talk a little bit today about why integrating and orchestrating all of these things is so hard. We found that it actually spans a lot more than just technology. And this is hard for me to even sometimes get my head around because I mainly spend my days, cracking open, some kind of editor and running ML code or running research code. But what I found, while again trying to do this at scale, is that the strategy, the people and organizational requirements, the security and governance, and now privacy requirements have to be weaved into all this, or your code isn't going to make it past your own laptop. Or whatever experimentation system you're in. And for me personally as a data scientist, and for my team, a group of data scientists who really have a lot to say, it's really discouraging when our work doesn't make it farther than ourselves. And that's actually a cause of attrition in a lot of companies. So it's not just about like the opportunity in the business side of things. I mean, yes, that's of course incredibly important, but if you want to keep your band together, this is something you also have to think about. So what I'm saying overall, and I think this is probably becoming obvious, is that production machine learning problems are oftentimes actually the organization problems that you had to begin with that are just getting layered into a new technique or new system of doing work. And so you've got to think about it holistically if you want to be successful. I actually wrote an article a few weeks back that kind of expands on each one of these themes. But as I was going through the research for it, I realized that there were 3 challenges that kind of stood out to me above all the other ones. And this is not an exhaustive list, but it's definitely areas that you can get tripped up on and we've seen our clients actually stumble with as they're going through. So the first is organization and political challenges. Like, I know no one wants to talk about this, but I know everybody in this room is experiencing it. So it turns out that machine learning projects are still projects. It turns out that like development workflows are still development workflows. Now, there are different techniques that you have to use, especially with a focus on experimentation and iterative design, that aren't necessarily shaped to traditional agile development cycles. It turns out that there are requirements for you to fund projects a bit differently, assuming or building in opportunities for failure that you probably never do with a SaaS application that had a deterministic focus. But still, the requirements of the organization and the requirements of sponsorship from leadership still remain. You have to have those things in place because otherwise, once you get to the difficult part of it, which is actually trying to build and scale this, any number of different factors, whether it be competition, whether it be cost, whether it be even challenges with technology adoption, can really derail things and can end up with your new capability actually not making it into the hands of your customers or to your users. I mentioned this already, but iteration and experimentation actually require different tools. And most times, the business users or IT teams that you're working with as a practitioner don't know what those tools are. And I'm sorry to say, but like there are a lot of experimentation platforms like Selvin or CommonML, or what Google's coming up with in their TensorFlow 2.0 pipelines that just like straight up aren't supported yet by IT and can't be because they need to be certified on regulatory practices that are in that particular industry. So what that means is that the way that you're doing your job or you're comfortable doing it actually has to go through an adoption cycle before you can bring it into a production machine learning system. So becomes this air gap between how you're doing dev and how you're actually going to do implementation and maintenance. And so that, again, requires, I think, executive level and also line of business level sponsorship to move through some of these challenges that are not germane to other projects they may be running at the same time. And the last thing I'll talk about on the organization side of things before we go a little bit farther into tech and architecture is thinking that it's somebody else's problem. I really don't know how often I've seen this, but it's probably I think it's probably every conversation I've had is that someone just points a finger and says like, well, IT will do it. IT says, well, that's not my problem. That's the DevOps team's problem. DevOps says it's site reliability's problem. Site reliability says, I don't know how to do that. The machine learning team should probably do it, right? And so this circular conversation continues to happen over and over again until you get to the point where nobody owns the end product. And what I'm really getting at is when you look at product development cycles for software engineering or even for just making physical engineering products, like for an iPhone, there are product managers for those components. There are defined budgets. There are outcomes roadmaps that are all orchestrated together that have an endpoint and have OKRs attached to them. Make sure you're thinking about that from a machine learning application perspective, because if you don't, then it ends up at the end with no one really being responsible for it. Even if it's the best outcome, the most transformational capability, it still doesn't matter if no one's in charge and no one's accountable. So the second component is about scale. So what I've found and what our team has found is that over and over again, there's this union between new technology that is relevant and enterprise expectations that becomes really, really important as we go to the production lifecycle. So what you're seeing here in this little diagram is just our example of like the simplest, most atomic form of what a model can look like. It's literally just inputs going into some kind of code-based scoring system. So it could be like Spark job, could be just a container that you've like put a Python application in, could be a Flask API. What really doesn't matter. And then the output is that you're providing some kind of prediction, maybe with some metadata in the exhaust, to a business system that's being presented as an interface to a consumer, right? So at the end of the day, it took 20 seconds to just describe what we're trying to do here, but the expectations on the enterprise scale are actually really robust. If you think about what it takes to deliver even like a production database system, something very simple to an enterprise, it really doesn't align well with what a prototype machine learning application looks like typically. You have to think about the security requirements. You have to think about compliance because that has to be reported at times to government agencies who are going to check whether or not it actually functions according to the way you say it does. You're going to have to check around privacy and of course ethical deployment, which is a big issue happening right now. So a prototype doesn't have to do any of these things, which means that the people who are building those prototypes often aren't thinking about them. So one of the biggest challenges we see is that there's almost a complete firewall between the dev teams, even if they do include engineering groups, and also with the sort of IT orchestration, architecture, and lines of business teams who are going to be required to maintain it going forward. And the biggest tension we see is that the lines of business and enterprise requirements, they have to protect the company. It's their job, and they're pretty good at it. So if you, as a developer, can't justify how you're aligning to the requirements, they'll probably just turn you off or say no. And that is a huge risk to innovation, as I think everybody would agree. We've talked about governance, compliance, and security, but I think another component of it is also dependencies, right? Now, as a dev team, you have a requirement to satisfy a whole other community of consumers that you weren't thinking about or care about before. And I think those relationships actually are not necessarily done organically or created organically. They have to be developed, again, through sponsorship and through deliberate activity. So the last challenge is around data and product market fit. I think there's, again, this tendency to look at the latest and greatest that's coming out from a blog post, or you might have seen demonstrated in a conference like this. And I get really excited about it too. I rush home, I run the demo code, then I apply whatever it was to whatever I've been doing before, and all of a sudden I've got this new production ML pipeline, and I'm super excited about it, and I'm ready to go. But that is typically just toy examples, right? They don't necessarily scale or align directly to the enterprise level of your problem. And my boss, Hillary Mason, likes to talk about this a lot, where she calls it the data product gap. And what it is there's a generic formulation of your problem, right? So think about if you're doing image analysis, going to reflection, or using one of the TensorFlow pre-trained models, and then scoring a bunch of images and getting either object detection out of it, or being able to use that for whatever downstream application you want. It's fairly easy to do. But then when you think about trying to apply it to a specific problem, like for example, one of the customers that I'd spoken to a while ago was actually trying to do essentially damage assessment on their planes, trying to understand if they'd had bird strikes or if there had been other particle damage that had occurred. And they wanted to use image analysis to do that. That is a highly specific problem. There's not really a very robust training set for it. And also, if you get it wrong, people will probably die. So you want to be really sure that you're getting that right. And all the regulatory requirements that come with doing anything in aviation get attached to that problem. So that is the gap, the difference between being able to actually implement it from a real problem perspective and what you're able to access from the open source or from the research community is actually a pretty large gap. And so there's three things that comes up in an enterprise conversation around whether or not you can actually execute these really cool things that you see. And the first is having the right data at the right time. And I know this sounds completely intuitive. Again, I'm not trying to talk down or around anyone. But the number one thing that the companies I work with fail to bring to the project is actually the data they need to solve the problem. And you would think that that would be the first thing that they'd worked on, or at least vetted and begun to work on, but almost never it occurs. And it's not just about having a volume of data and dumping it in an S3 bucket somewhere. It's actually about having the right data codified in a accessible, responsive location that doesn't require a bunch of security permissions that a data scientist who is working on dev might not understand how to do or causes them a lot of difficulty. And also, it needs to be thought of, can it be used in a production system? A lot of the banks we work with have a tremendous amount of research data, but they can't use any of it in order to train a model that makes a decision in real time because it's private. So those are the sorts of things that become an issue, and you would be surprised how many people don't think about that. The theme here is just because you can doesn't mean you should, and just because you think you should doesn't mean that it's possible for you to actually do. On the skills perspective, I think we are kind of alluding to it earlier when you think about the pre-trained or the AutoML community that's come up. It's really great for a lot of companies to do experimentation about what's available in pre-trained models or what's available in the AutoML space. But when it comes to making that specific non-commoditized formulation of your problem, it's also often possible that you don't have the team that can pull it off for that problem. You might have brilliant data scientists, but they may not be amazing image analysis data scientists. They may not be NLP experts. Or even if they are all those things, they may not have experience working with online predictions or working in Lambda functions. So there's now a divergence, or rather a specificity occurring in skill sets that requires you to have specific team members at the right time for a specific formulation of the problem. And that's a project level conversation that's actually really important for data science leaders to be having with the overall project sponsors to be able to execute. And the last part is the right conditions and the right time. So market conditions change all the time. And whether or not it is actually feasible or whether or not it's actually too expensive to execute a machine learning problem is something that needs to be considered as well. A lot of companies that I've worked with get to the training cycle and recognize that they have to run a train activity maybe once or twice a day. And then if they're running all the compute in the cloud, it becomes prohibitive for them. So that's another thing to think about. So the right solution for your machine learning problem adjusts for available data, skills, and time. That goes in with a theme before, which is that there has to be an overall program or roadmap for the product, regardless of whether or not it is feasible for you to execute. So the last thing I'll cover is some of the learnings of how some successful companies do it. First of all, they start with a strategy. They pick a set of small, very important projects, and they use them as a way to demonstrate success. So it quiets the naysayers, quiets the people in parts of the organization who don't think it's something that's machine learning or AI is a thing that we should invest in. But more importantly, it builds the muscle memory. So it forces you to go through development. It forces you to have integration conversations with other teams. It forces you to experiment. It forces you to fail. And the best part about it is you can throw away everything that doesn't work, and when it's time to scale, you have a roadmap for executing these things. The second is that they really focus on treating everyone in the entire design to development lifecycle and production lifecycle as a customer. So IT is the machine learning team's customer in terms of the machine learning team is building something that needs to be deployed. And so they have to make sure that they are building to a specification that is reasonable. From the ML team, IT is also, from the IT team side, ML team is your customer. They have to build a platform that the ML team actually wants to develop in, or else they'll go off platform and do it either in the cloud or on their laptop, and then this whole cycle we just talked about will repeat again. But I think this is intuitive, but the line of business consumers and the users are the customers of both. And so IT and the ML teams and all the enabling functions that are in between have to work together to deliver an experience that the consumer finds useful and also finds easy. And a lot of times, again, that pointing fingers on who's responsible becomes a prohibitive issue. I'm telling you, the best companies, they don't have that distinction. It's everybody's problem. They all work on it collaboratively. And finally, portfolio approach. So you've got to figure out which projects to prioritize and to fund. Obviously, that's true. But I think it's important to remember that not all enterprise use cases are created equal. And not every single thing that is possible to do is worth doing. So that's what I've got to cover with you. I think the last I'll close with is industrialization is all about enterprise transformation. It's not just about working or exercising the muscles of machine learning and AI. And the first companies that are going to figure this out are either already winning or going to win. So it's something to think about. Thanks.